Hello, today in our video, I would like to give a demo to use our Lab-on-the-Go hardware to do some experiments in our tutorial book. So as you can see, I've got the essential equipment here, Mago power supply, the Vago multimeter, and this multifunctional circuit debugger called Zular. I've also got a breadboard here and some components here to build the actual circuit. So first things first, I'd like to show how to use Mago to adjust the voltage you need. Well, now I turn on the power supply, press this button, and you may see the voltage reading here, right? So suppose we need to adjust the output voltage to 5.5 volt. I will use this mini screw here and just see the voltage is reading, the reading is going up. Let's just say 5.5. Yeah, roughly there should be good enough. Okay, so 5.5 volt. And you notice that this breadboard power supply directly feeds to a standard breadboard. So you have a quick and neat setup, right? And for myself, while plugging, I'd always recommend you to use to match the voltage polarity and with the marks on the breadboard. So I would do it this way. Just keep it plug in, push, and we have it done. Well, this entire power rail on a breadboard is internally shorted. That means every pin here should have the same voltage. Now, if I want to measure the exact voltage, I have to use a multimeter. So first, I have to set it multimeter into the voltage measurement mode. Turn it in this way, okay? And this meter is auto-ranged, so it will figure out the proper reading by its own. All we need to do is to stick out two wires, one connected to the higher voltage, the other one connected to the lower voltage, which we usually call the ground. So let's do it. Okay, now I take two wires. The red one goes to the positive, and this blue one goes to the negative. So it's ready to be measured. You know, one good thing of this Vago multimeter is that we have these alligator clips, which you can just clip wires so your hands can be free. Okay, let's just do it. So this one goes to here, the black one goes to here, and now we are in the voltage measurement mode. So let's just connect this. The black goes to the lower voltage or the ground. This one goes to higher voltage. Okay, now you see the voltage reading is 5.5 volts exactly. So now we measure the real voltage to be 5.5 volts, which matches to what we have set up on this Mago power supply. As you can still barely see, is 5.5. Okay, turn it off. Then we can build a simple circuit to test these bulbs. Well, we've got a tutorial that has a very detailed procedures here, so I don't think I need much explanations in this video. So why don't I just go ahead and build the circuit first? So once the circuit is built, we can turn on the power and we see the light bulb is on, right? So what if we just connect another bulb in parallel? So this side goes to the resistor, the other side goes to ground. And we can see, I'm not sure if you can see it clearly, but obviously the intensity of the bulbs is getting dimmer, right? We can still see a faint light here. This is because you distribute the same amount of power into two loads that less energy is delivered to each of the units, right? So we just take it off. And you also notice that we use a bigger size of resistor here. And this is because we want the power, like a rated power of the resistor, to be much higher than the actual power or the heat dissipated. So if we use this kind of a smaller resistor here, they may get heat up very quickly and cause damage. Well, since the Vago multimeter is capable to measure the temperature, why don't we just do an investigation on how the temperature and power is related? So we have this thermocouple probe here. It's quite easy. We just connect the black to the common, and this one goes here. And you see we have the temperature adjustment mode. We put it here, and it can measure either in Celsius or Fahrenheit if you press this selection. So it can be in Celsius or Fahrenheit. So I'm just using Celsius mode, and I put the metal contact here on the object I'm about to measure and see what temperature it is. Okay, it's about like I'm saying I would rather wait few seconds to make it stable. So looks like it's about 50 degrees, right? So it's getting hot, but not that bad, right? Imagine if you use this kind of a resistor, it's getting dark quickly and may get damaged. So in this lab, I'm using this Mago power supply and the Vago multimeter along with some of the accessories and the components and build a simple Watt's law circuit on the breadboard. And we test the relationship between the power dissipation and the heat and the light intensity. So now it's time for Zulark, and I will use a different circuit for demo. Okay, I have the circuit built. This is a transistor-driven motor circuit, which you may probably see in our Kickstarter camping video. And this circuit adjusts the motor speed by tuning the duty cycle of a PWM control signal. So I'm setting Zulark into the PWM mode. And as you can see, now the duty cycle is 95%. So what if I just turn on this power supply and we notice that the motor rotates, right? And you see the second motor rotates. And if we just lower the duty cycle, you see the motor speed is changing. I hope you can see this in the video, but yes, in fact, and let's just tune it into a proper speed. Okay, leave it here. Well, the second motor you see is rotating because the wind pushes the propeller. And according to Faraday's law, we should be able to detect induced voltage generated at the two terminals of this motor. So let's just hook up a wire to the oscilloscope and let's just visualize the induced voltage. Okay, so let me just grab a wire and connect to the channel 1. Okay, this is channel 1, and we hook up the wire here. This is the induced voltage, and we have to change that into oscilloscope mode. So let's just see the waveform. It's like here, and yeah, I hope you can see that. And let's just adjust the time slot a little bit. So you see it's a sinusoidal waveform, which is, you can see the LED is blinking because the frequency is about 34 Hertz. Yeah, I should be able to see that. And the Zulark has 2 channels. So I have built another rectifier circuit with this diode. And let's just connect this to channel 2 and let's see what's the voltage appear here, right? You see channel 2 is a straight line because we first build a rectifier circuit to only get the positive portion, and we use this capacitor as sort of like a damper circuit, so we see it's becoming a straight line. This is a circuit how you convert an AC to DC. Well, if I just unplug this capacitor, you see it's being rectified. So this is the rectifier signal where you clip everything below 0 and only keep the positive portion. This is what this diode do. And you if you connect this capacitor back to the circuit, you see it's becoming a straight line. This is how it works as a rectifier circuit. So yeah, so with Zulark, we can clearly see the waveform and do some measurement. If we connect this Zulark to computers, we are able to export the data and do some averaging or some advanced features or data analysis. So this video is just a quick demo of the thing we have. You should be able to find more details and the systematic learning in the tutorial book. And we also launch a series of ongoing cool projects. So please stay tuned to our channel or subscribe on our Facebook or LinkedIn channels. And I will see you next time. Bye.